Welcome to For Every Response, the podcast from Emergency Services Times, sponsored by MSA Safety. In this series, we bring you sessions from the Emergency Services Show and the Emergency Tech Show 2025. This is a packed episode with the Civil Aviation Authority providing an update on the latest position about using drones beyond visual line of sight. They are joined by leading academics who are looking at using swarms of drones to detect wildfires, providing a level of situational awareness never seen before.
We're going to hear from two interesting groups in this session at Imperial College, who've done some fascinating research. But first, if I may hand over to Sophie from the CAA, who's going to talk about what they've been doing.
Thank you very much. Good to see everybody here today. Hi, I'm Sophie. I direct innovation at the Civil Aviation Authority. So we look after the safety of drones in the UK. What I wanted to talk to you about today, and I think there was going to be an accompanying slide that was going to come
on the screens behind you.
Hopefully. There we go.
Yeah.
Thank you for that. I've only got the one, so I don't need a clicker, but I appreciate it. So what we wanted to start with today was really talking about why the CAA are here today at the Emergency Services Show to particularly talk about innovation and about drones. Some of you may have seen the CAA strategy, some of you may have not, but predominantly what we're really aiming to do is to enable innovation, but to do that safely. That's a lot easier to say than it is to do, and I'm sure many of you will appreciate that. So what we're really trying to do is to push the boundary of what you can currently do with drones, with RPAS, but to do that in a way that we minimise the risk of loss of control, we minimise the risk of mid-air collision, and we try and do that with the best competency possible, really to adhere to the state safety objectives that we have in the UK. So we've heard a lot of feedback from you as part of that journey to innovate and to do that safely. And we're really, really aware that a couple of years ago, you were finding operational safety cases, and even further ago than that, standard and non-standard permissions quite lengthy to do. They were taking quite a long time. You had some issues with the systems that were doing those. And we've really heard that. And in response, what we've done is we've set up a large programme of change, which we've called the Future Flight Programme. And that's been funded by the Department of Transport. And we've also launched our PDRA 01 service, which is referred to on the slide, where we really took the average processing time down of that application to 30 minutes from a number of days. And we've had some really positive feedback from that. And there's a lot we think that you can do as police forces or as more broadly non-military state actors within PDRA 01. So operating within commercial areas, industrial areas, recreational areas, 500-meter radius, 25 kg or lower in terms of weight of the drones that you're using. And we've really seen that enable some use cases in emergency services and for non-military state aircraft. Furthermore, and also in response to similar feedback, we've launched our SORA platform, which is the third bar down on the slide, as recently as April 2025. I think we hit the last day of April, if I remember correctly. And that is a risk framework for drone use that's been created by over 60 countries. We work with the JARIS community, some of you may have heard of that, to bring about this risk framework to really enable specific category operations in the BVLOS category, so beyond visual line of sight. It would be helpful for me to understand, are any of you here drone operators in the police today or in...
Yeah, one at the back.
One. Okay, good. Two. Okay, so you know what I'm talking about then, hopefully. Good, that's two of you, that's helpful. So hopefully you've seen PDRA 01, hopefully you're using it, you've seen the SORA application. And look, it's really important that we work to real world outcomes. So I really wanted to make the point today that only yesterday we approved our fourth SORA application. So this is something that we're really seeing having real life examples. We've approved some operations for infrastructure surveillance, for drone in a box, remote use across London. Equally, you might have seen some of the work that we've done with London Health Bridge, where we've enabled hospital to hospital transportation of pathology samples, across some of our busiest airspace in the UK. Or you may have seen the work that we've done with NPAS, who are here today and who we've been talking to, who we've been able to work with to enable one of the largest drones, the Sheeble Camcopter 100, I believe it is, that's over 100 kg in weight. That's been operating in a temporary danger area, and we're working with them to enable that operation to do even more in different airspace constructs that we're calling a temporary reserve area. So I use those examples to really highlight the things that we're doing and the outcomes that we think we're driving in terms of enabling operations to work in an innovative way across emergency services. Now, all of that being said, we are very aware that when you're an emergency service, you have to respond to an emergency sometimes. The clue is in the name. So there are going to be instances where you're actually not able to wait for a Civil Aviation Authority person to talk to, for a permission to be approved. You may need to respond to something very quickly. We really, really recognise that, and we understand that. And using that, we've created a policy that we shared with all of the accountable managers across police forces and with our stakeholders across non-military aircraft actors in the UK this week, talking about how we would like to propose a policy where, when you are planning an operation and you're planning it, so you might be planning to do a beyond visual line of sight trial, for example. Maybe you want to trial a new type of detect and avoid technology. Maybe you want to trial a different type of operation that you haven't before. Where that's planned, we would really like you and ask that you work with us, that you use the regulation that's available today. Could be the open category, where there's very limited regulation. We ask you to do a short competency test and get an operator ID online. Could be PDRA 01 that I've referred to and some of the operational limitations that you have there, or it could be using the SORA platform. When you really can't do that, what we're proposing is that there's a different category of operation that we're calling Type B. So we split operations into Type A and Type B. And with Type B, what we're saying is we understand that there may be instances where you need to respond and do something rapidly with your drone. If you think that's going to happen in the entity and organisation that you're working in, come and talk to the CAA, email us, and we would like to create a specific agreement for your organisation whereby we agree to share data retrospectively after you've done the operation, but where you've got that freedom to operate where you need to. A lot of what we're trying to do here is to have that flexibility, enable you to operate and respond when you need to, but also to manage the mid-air collision risk in the UK. I'm sure you're all very aware that drones are not the only aircraft that are in the UK airspace, which is pretty crowded, it's quite busy, and it's predominantly quite complex. So we need to balance having as much knowledge before operations as possible so we can manage that mid-air collision risk. If you work with us about an operation that you're planning, and maybe we have found out that there's going to be a temporary danger area in an area that you're looking to work in, or maybe there's something going on in controlled airspace around an airport where you might be near to, something like that. We can work with you to share that information. We can help you de-risk the airspace that you're operating in. And that's why, where possible, we would like to work with you before operations, but because we understand you really need that flexibility, we're suggesting this policy where you can also have a data sharing agreement with us to use Type B operations. So hopefully that has given you a good overview of really what our strategy is in the UK, what we're trying to do in innovation, how we've responded to some of the feedback that we've really heard around efficiency and effectiveness of our processes and of our approvals, and hopefully how we're showing some flexibility when it comes to emergency unplanned operations, but giving us information that we need to manage the total air risk picture in the UK, which ultimately we are responsible to do. I'm with my colleague Keith, who is an ex-policeman. I think that's how I should refer to you.
I think you can say that.
And is there anything you would like to add?
Yes, so we've been here over the last 2 days to share with our colleagues, with the emergency services, this Type A and Type B policy. So to give you some background, up until about 18 months ago, I was a police sergeant with West Midlands Police, and I had a team of drone pilots flying throughout the West Midlands. And I just wanted to kind of share with you how proud I am over the last 6 months or so that we've kind of developed a policy now that enables emergency service, and that's not just the police. We're talking about the wider emergency services such as fire and rescue, ambulance, search and rescue, for example, because there are those times where pilots, emergency service pilots, are out there protecting the public and keeping the community from harm, where they may need to, in a critically in an incident which is critical, may need to breach those regulations. And the Type B policy gives the organisation that framework. So yeah, we're here for the next 2 days. Come and talk to us. We invite that feedback, and part of our continuous improvement is to form a non-military state working group, so that we can continue those discussions, share best practice, and encourage the use of drones. Because there's some fantastic work going out there. It's really hard not to be amazed by the technology that's being used in our communities day in, day out, whether that's finding missing people, vulnerable people, capturing people who don't want to be caught, the police, and some of the other innovative ideas around, transportation of life-threatening technology in really remote locations. And this isn't just about protecting a small group of people. This is the community, and it's much wider than that. So actually the fire service are using drones to protect their own, to protect their staff. So this is a policy that some may say is a long time coming, but it's here now, and we're accelerating that now so that it can start using throughout the emergency service sector.
That's great. Sophie, Keith, thank you so much for that. Let's hear now from Mauro and the research you've been doing.
Shall I start? No questions?
You're welcome to stand there if you wish. Yeah.
Right. Well, good afternoon, and thank you all for coming today. So I'm Mauro Innocente, and I am the founder and a research engineer at SwarmMind, and I collaborate on this topic with Imperial College, Professor Peiro sitting there. And my work basically consists of turning cutting-edge research in swarm intelligence into practical solutions by designing bespoke swarm systems which are reliable, resilient, adaptive, flexible, scalable, self-organizing systems for challenges such as wildfire emergency response. Now, the concept here is that self-organizing systems rely on emergence, which is very hard to control. And that's what we do. By controlling emergence, we are trying to make swarm systems deployable technology. So that's what we do. So as a former academic, I like building my case from the ground up. So I'll start here with the case for wildfires. As we know, wildfires are becoming more frequent, larger, more intense, and they last for longer than ever before. And this is the case everywhere in the world, even in places that were not prone to wildfires before. They are now appearing there as well. This is straining, challenging emergency services worldwide. This is also the case in the UK. And in fact, 2025 is a record-breaking year in terms of number of wildfires and total burnt area, by a large margin beating the previous record in 2019. So this is becoming a serious problem in the UK, and this is a problem for which the fire services are not ready. So if you use drones, so in 2015, as far as I remember, it was the first time that the fire service in the UK had a drone unit. So they started working with drones. I think it was Manchester in 2015. So before then, it was virtually non-existent. And even in 2015 and in 2017, when I started working on this, almost no fire services, very few were working with drones. And they were mostly reluctant to adopting the technology. Yeah? Since then, it's been 8 years, and now it's in everybody's toolkit. It's everywhere. So it's a standard technology in the fire services. 8 years ago, it wasn't there. So new technologies are coming, and fast, to help address these new challenges. Yes, the fire services must adapt, every emergency services must adapt to this new landscape of increasing wildfires. Now, there are many advantages. Here in these images, we have some of the tasks in the three phases of wildfire emergency response: pre-fire, post-fire, and during the fire. All the kind of tasks, missions that can be done using drones, for which some of these are being done today. There are several advantages for drones, like increasing situational awareness, cutting through smoke with thermal cameras to identify hotspots, search and rescue operations, delivery of essential supplies, medical kits, and so on. Many advantages. Some of these help keep the firefighters away from the danger zone. But there are some disadvantages, some difficulties in adopting the technology. The main one originally was regulations, but as we know now, there are some exceptions and there are some approvals via SORA to operate in emergency services beyond visual line of sight, so we are going there. Correct me if I'm wrong, but I think the plan is for 2027 for this to be more common operation, not so special, more common, beyond visual line of sight and with some level of autonomy. So we are going in that direction. Now, another big disadvantage for drones is the lack of scalability. So as you see, you have one drone, there is only so much that one drone can do. You want to do more with more drones, you need more operators. And more operators operating with a one-to-one drone means that it's very hard to coordinate between operators, coordinate between the drones, let alone coordinating with the other systems in the air or on the ground. So it becomes too complicated and also very slow coordination. So you want this to be done autonomously in a swarm of drones. That's where we come in. That's what we are doing. So why use a drone swarm? First, I'd like to define what a swarm is because it's a loosely used term, in my opinion, not very accurately used. And generally, they mean a group of drones or a fleet of drones is a swarm. In my definition, a swarm must develop some emergent properties, some collaboration between the drones to be a swarm. So that means that they self-organize, they collaborate, and some properties and the higher level capabilities emerge. And that's why I said controlling emergent allows you to design them properly to do what you want them to do. Okay, so that's a swarm. They self-organize to produce a higher level behavior, higher level intelligence. In my definition, a swarm system exhibits swarm intelligence, and that's what we do. Okay? With this definition of swarm, why would you want a swarm? Well, first, they self-coordinate autonomously, so it's a fast coordination, and also by collaborating, they can solve much harder problems, much more complex because they have a higher level of intelligence. You can design them to do different things. So comparing this to an equivalent monolithic system, a swarm system is cost-effective. Yes, it's very cheap by comparison. It's distributed. It's safe and efficient. It's a swarm intelligence system. So the meaning by this collaboration and this emergence is that what it can do is more than the sum of its parts. If you are using them for surveillance, for instance, or for exploring or monitoring a large area, it doesn't mean that multiplying the number of drones by 10, you will cover 10 times more ground. No, the concept is that it's more than the sum of its parts because it exploits intelligence, it exploits the information it gathers, it exploits collaboration to do this more intelligently. So it's a scalable system because it's robust and massively redundant. You can lose drones and it still works. You can merge swarms, you can split swarms. You can see some examples at the bottom. One is fire suppression in simulation, of course, and the other is collaborative transport. And those are kind of case studies for a proof of concept feasibility study. And you can see, you can imagine some operations where you have a swarm suppressing a fire that is under control and you need to deliver some essential supply somewhere. You can seamlessly take some drones out to do this other task. You reprogram them for another task. The others keep working because it's scalable. You can lose drones during operations and it still works with the graceful degradation of efficiency, but it works. And then the other drones can easily come back and merge. If this is not enough, you can bring another swarm from another fire brigade and merge them, and so on. So you have all these properties of a swarm system that are very, very advantageous. Now, how does these features translate into benefits for fire services? Well, you can have much earlier detection. You are covering much larger ground for your monitoring. Therefore, you have earlier detection, faster response. You can take action because they can collaborate to take action, like in fire suppression, directly upon detection. So if the first attack is immediate, persistent monitoring, much better situational awareness. So you have all these advantages of using swarms. Now, what are the complexity? Well, how do you design the agent behavior so that when they all interact, they do exactly what you want? This is in general any engineering systems. You have some specifications, and then you design for these specifications, verifying the behavior, intended functionality, and so on. But here in this inverse problem, you have emergence, which is what makes it much more difficult than traditional engineering problems. So it's a traditional problem, inverse problem, specifications, verifications, but the design includes emergence. Controlling emergence, we can do this design. And therefore, you can specify different missions, and you retrain the algorithms for that mission, you verify that the intended functionality, and you can use the same swarm for different tasks. Okay, here we have some example of missions that you could do with swarms. Remember, this is not an existing technology, it's a proof of concept, and it's proven in technical feasibility studies. In this example, I'm trying to show that this needs to be integrated, not added on. So you see a swarm of drones that are performing suppression and monitoring activities while simultaneously are taking measurements of wind and temperature. With these measurements, with AIs, convolutional neural networks, we downscale it and map at the high level, at the drone level, the wind and the temperature fields. Then another convolutional neural network maps it down and feeds it into a wildfire modeling software, the wildfire simulator, wildfire propagation simulator. So with this and data simulations, you can improve and enhance the predictions. But you are doing this while doing something else. While you are suppressing a fire, you can take those measurements, so you can do more than one thing at the same time. And this is one of the main things here, and it actually applies also to single drones. Usually, because they came later, the services buy a drone and they are adding it to the current systems. So this should be designed, of course, it's easier said than done, but the whole point here is that they should be designed as an integral part of the response system, not as an add-on, and the same with the swarms. If you do that, then you can do all these things simultaneously, just because it has been designed for. If you add it later, then it will be clashing with other systems that were not designed to interact with this one. Okay, but this exists for single drones as well. Okay, so what are the implications for the emergency services of this technology? Well, this is highly disruptive. It's a new technology, so it will require some training, some new infrastructure. There will be some blocks by regulations, but we are on the way, because really the first step towards this level of autonomy are beyond visual line of sight, which we are moving towards 2027, and it's different levels of autonomy for single drones. Once this is done, the next step is swarming. Okay? So this is something that is not as far away as you might think. But for that, we need a bit more maturity in the technology. So not many people are working on this as far as I am aware. So there is more research needed in this technology and in all the different actors. So we will need, and this is a call for action, so this will need the collaboration of all the different actors, from the emergency services to the regulators and all kinds of technologists, drone companies, software engineers, communications engineers, all these people that I've seen around here that are integrating all different kinds of holistic system with the cloud. So all these levels of technologists, plus emergency services, plus regulator working together to make this technology a reality in a not so distant future.
This episode of the Emergency Services Times podcast is sponsored by MSA Safety, proudly supporting emergency services and first responders on the front line. At MSA Safety, protecting first responders isn't just what we do, it's who we are. We work closely with fire and rescue services across the UK to develop and deliver safety solutions designed to meet your ever-evolving needs. That includes MSA Bristol Firefighter PPE, trusted by services across the UK and beyond, shaped through years of collaboration with frontline teams. It also includes our growing investment in innovation and technology, from the connected M1 SCBA modular solution to our agile, fully managed service model that helps keep crews protected and ready to respond. But for us, safety goes beyond equipment. We believe in standing shoulder to shoulder with the people who dedicate their lives to protecting others, whether it's supporting firefighter charities, backing mental health initiatives, or showing up for community events. MSA is proud to be part of the emergency services family. To learn more about our work in the UK and how we're supporting first responders every step of the way, visit www.msasafety.com. With MSA Safety, when you go in, we go in with you.
Just compare these two different approaches, because Mauro's talking about drone swarms here, which, if you've ever seen Black Mirror, is an absolutely terrifying concept, but he's outlined beautifully why this is a good thing. But the barrier to this is regulation. Now, you guys at the moment are regulating for individual drones, and Keith, you've been on the front line of doing this. How is the CAA looking towards the future of regulating to allow for this kind of drone behavior?
Shall I start?
Yeah.
So I wouldn't describe regulation as the barrier, because you can have drone swarms today, and hopefully some of you have seen those. So if you've seen any of the New Year's Eve displays where it looks like very kind of complex fireworks in a way, that they are drone swarms that are being used and are approved by the CAA today. What we do at the moment is we want to understand the software that you're using, so we can understand each waypoint that the drone will end up going to, and we want to make sure there is that return to home functionality, and that we've got the kind of right buffer zone between uninvolved third parties, because as that Black Mirror episode highlights, and I have seen that, I'm not sure it was that helpful for our sector, but equally it's a good warning, I guess, in some respects. But what we're able to do is, by checking that you've got those mitigations in place, the buffer I've talked about, the return to home, us understanding the software that you're using and how it works, we are able to enable swarms today. And I think what's really interesting about the use case that you've put up is one of the ways that we really mitigate in terms of safety right now is we want to make sure that there are not people on the ground that could be impacted. And obviously, by its nature, you would hope that within a wildfire, you hopefully do not have a lot of the population that's there. So that actually, I think, gives quite an opportunity in terms of mitigation when it comes to population density. So look, can we do everything that possibly you've referenced today? I'm not sure. We do have some work to do in terms of the autonomy, complete self-deciding machines, if they're going to organize themselves, and you reference that kind of them doing that with a human possibly giving some oversight. What we really need to understand is, what does that really mean? How much oversight? How often? How does that human intervene? What are human factor elements that you might want to consider around that? All of that type of thing. But that's very much something we're working on. It's part of our Future Flight programme. We're working with the Law Commission to look at how you might have the legal infrastructure when it comes to actually having full autonomy. At the moment, we're working on our multi-simultaneous operation policy, which we really see as the first step. Because at the moment, if you've got one remote pilot to one drone, if we start to scale that up with MSO, multiple simultaneous operations, we're really testing that concept, and then you can look at how might you have the legal infrastructure and how might you then move towards more autonomy. So that's going on in the background. That's part of the program you referenced to enable more of that type of operation by 2027. And at the moment, we are able to enable some swarms in limited fashion, and I'm very hopeful for what we can do in the future. Anything to add?
I'd encourage anybody that's looking to use drones in those kind of situations to contact our team so that we can give you advice. And there's the tech strat team are there to give advice on those types of operations, to give you a steer and to kind of support you with that kind of operation.
And Keith, having been on the front line, having had that controller in your hand, having managed a team, how do you envisage swarm technology might be useful for the police service?
You tell me, how could that be good for the police service? Have you got any use cases?
I haven't studied the police use yet, but yeah, probably tracking, like you use it for search and rescue, maybe tracking someone escaping. I don't know. I need to think about it.
But thank you.
There are other situations, for instance, when when you get large gatherings of people,
Yeah.
okay, where scrummages, small problems arise within the crowds. It's going to be extremely difficult for the police on the ground to be able to identify it. While if you got a monitoring system like drones overseeing that, would be able to identify spots that where the police on the ground might need to act, and then say, okay, you need to go there and do something.
Yeah, I agree. You know, situational awareness is fantastic to have, especially as a commander when you're commanding an incident. So in my experience, we used drones to give live situational awareness back to our control rooms, for example, whereas historically you would rely on people on the ground through radios to describe something is happening. But how fantastic it is for a commander to be able to see exactly what's happening on the ground so that they can make those decisions around resourcing, etc.
Possibly you could make some predictions as well. I mean, seeing the pattern of what's happening, say someone running away, seeing the prediction, maybe you can predict what's going to happen and take action in advance.
Yeah, it is exciting times. It's a great space to be in. I'm so grateful that I'm still involved in the world of drones.
It is exciting, and there is lots to sing about drones. But it is important, especially if you're in the audience and you've not worked with drones before, to keep in context their limitations. You know, they're not perfect. There are weight limits that you mentioned. You know, I see a colleague from the Coast Guard sitting there. You can't send a drone 100 miles offshore. That's a human in a helicopter. Can you just lay the land for us on actually where drones stop and where you need a qualified pilot in a helicopter?
Yeah. So our whole risk methodology is around exactly that risk. So it depends entirely on the size of the drone and where you want to use it. So our CAA website has got all the information people will need, whether that's a hobbyist or somebody that's using it for commercial or, emergency services. Everything is there to steer you and signpost you towards becoming compliant and legal. But it would entirely depend on the size of the drone and where you want to use it.
And what about the environmental limitations, weather, distance, geography?
I would put the question in another way. If you are in a search and rescue mission of a person on the sea, who stands a better chance of finding the person? A human in a helicopter or a set of drones that might have better visual capabilities, better technique to recognize a person on the sea? So that's obviously the drones have got limitations in terms of autonomy, endurance, range. Okay? But there are certain circumstances. Essentially, in any system, you need to look at the elements and use each of the elements to the best of their abilities. Humans have got limitations, but they are very good at certain things. Okay? So you need to use the system with the humans at the best ability and the drones at their best ability. Okay? So, for instance, visual monitoring, drones a lot better than humans. Monitoring temperature and other quantities in the environment, drones are better. Making decisions, humans are better. Okay, so it's use each of the elements of the system to the best of their ability, and then you get the best possible scenario.
In your research that you've done, have you looked around the world at other countries that are pushing forward with drones? Where does the UK sit in the context of other nations?
Very low.
Pretty low? Why do you say that?
I'm talking in the context of wildfires. Okay, so in that respect, the UK is one of the places with fewer wildfires around the world. There are other places, both in Europe and in North America and South America, where wildfires are more severe, the damage is larger. Okay, so those places have got a much vested interest in developing this methodology. Okay, I don't know in other areas like surveillance, rescue, and so on, but the countries leading the research in this area are Canada and the States, and the reason is very clear. Okay, is where there were the larger wildfires and where the losses due to the wildfires are higher, both in terms of deaths as well as financial.
Yeah, interesting. Do we have any questions? Would anyone like to ask anything from anyone on the panel? We'll get a microphone to you if you want to stick your hand up. In the meantime, can I ask, you started off by saying this is about drone use across the emergency services. I think it was last year we had a session with the Scottish Ambulance Service who were sending defibs out on drones. The year before, we had a session with, I think it was NHS Scotland, sending medication to the Highlands and Islands. Obviously, you've talked about your policing experience. You guys have touched on wildfires. Is there one service in particular that's really kind of steamrolling ahead on this and really keen to embrace it?
Shall I start?
I think that the most evident applications of drones is, for instance, during natural disasters, floods, earthquakes. There are deaths, but there are survivors, and looking for those survivors is dangerous. Okay? And drones are specialized in dangerous, dirty, and dull activities. So if you want to look for people on the rubble, it's always better to send a drone and try to identify than whether the person is there and is alive, rather than even sending dogs, because you might lose the dog or you might lose a person if the person gets looking for that particular person. Okay?
I think what I would add is, obviously, as the regulator, in many ways, we think about the use cases, but we also want to make sure in some instances we're almost use case agnostic, because we want to make sure that all of the safety parameters and the mitigations for those that I've referenced are adhered to in every case. But we really do see quite exciting and developing use cases in the area of infrastructure surveillance, emergency services, healthcare, and then also that kind of last mile delivery, that ability to really deliver products, whatever it might be, without needing to necessarily use vans and cars, and the environmental impact of that, which is positive, we see and we're quite excited about. So it's mixed, but I think definitely those four kind of sectors in that quadrant we see quite a lot of demand in. Do you agree with that, Keith? Anything?
Yeah, absolutely. Working on the non-mill state policy, one of the jobs was to look at who our operators were, who could be enabled by this policy. And it's amazing because there's far more than I actually could think of who may be enabled by this. So it's a gift to them, really, because this will enable them to go out there and protect people.
Remember that we are in the Amazon stand, and Amazon has put proposal policies for autonomous delivery of packages using drones. Okay, which I suppose it doesn't fit within the emergency setting, but certainly a commercial activity where drones can play a part.
Yeah.
I am exploring on precision agriculture as well, which is looking like soon will be an emergency. So maybe this can help avoid that.
Yeah. Sophie, one of the things you mentioned in your introductory speech was the crowded airspace element that the UK has. And obviously the CAA has to manage that, has to deal with emergencies, has to deal with calls at 2 a.m. from a police force. And here you've got two guys saying, no, sod one drone, send 50 up. How are you going to address this?
It's a very good question. And it's a lot of what our large change program that I referenced is really thinking about. And it's going to need to be through a series of policies that mitigate the risk of mid-air collision effectively, because that's what you're describing, that the more, put in a very simple way, the more things that are in the air, the more you are loading risk into that system. So what we need to have is a series of things, situational awareness, what we call kind of good comms, navigation, surveillance, how you might detect, take avoiding action, what rules of the air you might follow, how you might be electronically conspicuous. I'm just kind of listing off a ream of policies really that will enable us to do that. And the more that you can use services. So we talk about things like unmanned traffic management, unified traffic management that might give you weather services, pre-flight planning, information services, all these types of things that you can access. Once we get these policies ready and launched, you will be able to do more with more aircraft in less airspace. That's the idea. So the more that you have that ability, the more that you can scale up. While we're waiting for those things to land, we do have to lean on things like separation, segregation. But what we say at the CAA is let's always use that as an opportunity to learn and really think about that crawl, walk, run type innovation spectrum. So even if you are doing something in segregation, please share your data with us, whether you're trialing a new type of detect and avoid, a new type of platform, whatever it might be. And then that enables us to build our data bank, build our confidence so that we can then hopefully use that to put into these types of policies, launch those, which eventually should enable the scaling up in the UK. But that's not an easy thing to do. It's particularly complicated, which is why we need a little bit of time to do it. But it's very much something that's in progress.
Yeah. I'm Scott Thompson. I'm from the Scottish Fire and Rescue Service, so very interested in wildfires. And we've talked before, or we've done demonstrations before on the wildfire things. What I was more interested was, where are we now with drones and the ability to do those drop-off packages, to carry a payload, to actually drop something off? I'm thinking more in terms of the emergency services, where we can transport payloads and drop it at a scene, which is one of the things that we would potentially find very useful. I know there's obviously restrictions around that just now. Where do we see the future going with that, and how long do you think it would be until we're at that stage?
Do you want me to start?
Yeah, please.
Sure. So, I mean, I don't want to give quite a lot that would depend on the use case. So what we would want to understand, and particularly that we kind of describe it as last mile delivery, that last bit of the drop off is probably where there's quite a lot of risk mitigation that we would need to work together on. So that's where we would want to understand the type of location. And it's not that everything has to be location specific. We are really working on how do we enable the right technical mitigations that you can use in multi-location, because we totally understand the feedback, and it's very reasonable that if you need to do that for every single location, that's not that scalable. So in some instances we will ask for that as we're maturing, but we're really looking to change that. But to come to your question, really that's going to depend on the overall risk of the operation, which we would describe in sales scores. You might be familiar with that as part of the SORA methodology if you're looking to do it beyond visual line of sight. So we'd want to understand, what is it that you're dropping off? Is it a dangerous good or not? That would give us some regulation. We'd have to think about competency of those that are doing your operation. What type of aircraft are you using? How heavy is it? Are there going to be uninvolved third parties? What type of location is it in terms of airspace? Are you near crowded airspace? Are you near schools, prisons, all that type of thing? But once we've worked through all that, but there is possibility today to do that sort of drop off that you described. That's part of what London Healthbridge are doing. So probably we need to know a little bit more about the specific use case, but it sounds doable from the high level description that you've said, but we'd have to work through those things. So maybe we could have a talk after.
I would also encourage you to jump onto the SORA website.
Yeah.
Because free tool on there that will enable you to put in your use case, and it'll actually give you a sales score, which will give you an idea of the kind of mitigations you'll need to have an operation like that authorised.
Hi everyone, my name is Mike Edwards. I'm a partner at Ridge & Partners. We're a built environment consultancy. Prior to that, I'd been working on drone-in-a-box technology and worked on a few of the future flight programs that you were mentioning earlier. I'll try and ask the question to cover each of the panelists. So looking at the drone first responder program, drone-in-a-box, we've currently seen a lot of examples and use cases from different constabularies, both police, fire services, ambulance, search and rescue, almost acting in isolation. Is there a concerted effort to bring all of those different applications together to look more at a shared infrastructure whereby drones in boxes are deployed for multiple use cases across different stakeholders, and then bringing that back to the swarm question, rather than deploying a swarm of drones all at once, are you also looking at how networked drone boxes could act as swarms for that emergency response type application? I suppose a question for Keith in that as well is around DJI drones in particular, Chinese manufactured. If you could make a mention to whether there are concerns around those types of systems, and are we moving to a more UK manufactured type technology infrastructure? And I suppose for Sophie, around that idea of moving from drones as remote control helicopters to drones as infrastructure, is there an approach to look at a shared, or what I would refer to as an automated drone infrastructure, much more like how we work with satellite technology as opposed to drones as they are today as remote control helicopters?
Great, very detailed question. Thank you for that. Let's start with the practical first.
Okay.
And then we'll get on to the theoretical. So the practical of sharing drone resources, uses, and a drone infrastructure.
Do you want me to start with the?
I don't think the Civil Aviation Authority is the most.
I know a lot of the emergency services from past experience are talking a lot around DFR, and I completely understand the concept. But I know they're already working and talking together, because that's the way that this is going to move forward, isn't it? By that collaboration process. So it appears the sensible thing to do, doesn't it?
Yeah, and ultimately the thing I would add is as the Civil Aviation Authority, we receive applications. So it's our job to have an open-minded approach to those, to be looking at the trends, feeding that into policy that we need to create. But ultimately, that type of collaboration, it's very helpful if it can start at the application level. So actually we get consortia coming to us, and we do see that in some instances. That, and then that kind of, I don't want to call it groundswell, but that demand, if we start to see that gives us more data to then say, possibly to government, that we're really seeing larger and larger consortia. There's maybe a use case here for that shared infrastructure. So I think we can be really part of influencing, but ideally we start to see that demand. That would help us.
I do love the idea of that drone mesh. Okay, so on to the theoretical side of that, especially related to drone in a box. What's your response to that?
Yeah.
I think from the economic point of view, it would make a lot of sense if you could have a centralized facility of drones that could serve all the emergency services. But the question is there a type of drone that fits all the possible missions that the emergency services can have? Or would the emergency services have drones that are specifically designed for their particular mission? Okay, so I think that would be, financially, it would make a lot of sense to have a centralized hub of drones that will serve the emergency services, because let's face it, the drones are not going to be used 24/7. Okay? But on the other hand, the requirements of the police service might be completely different from the requirements of the fire service or the ambulance service, and they might want their own drones specifically designed for the missions that they want to serve.
Yeah, Mauro?
Well, I agree that some of these specifications will coincide, so that is still a very good idea, I think, because if you want to do search and rescue surveillance, it's the same kind of monitoring, whatever it is, it's the same kind of specs. So, and the kind of payloads that you have in today's technology in drones are pretty much the same thing in any applications, just details. So in some cases it will be optimal, some less optimal, but it can work. So I think in principle it is a good idea financially and not crazy operationally. I can foresee it happening.
Yeah.
And I'm not sure I understood, but then you also mentioned not to deploy a swarm all at once, but in a network, you said? So instead of a swarm, you have drones, is still a network. So the only thing there would be the communication. So it's just a spatial extent much larger wherever they are. And you can have all kind of connectivity. Instead of one drone, like you said, you could have a small swarm of 3, 4, or one, as you say. If they are connected, however they are connected, then it's still a network, and they can swarm whenever needed, operate individually, swarming in splits. It's just managing the connections, the connectivity of that network. Yeah. Now you have one disadvantage, that you lose the decentralization, because something that large, you will not be connected node to node, drone to drone everywhere. You will have some central hub, and you lose the resilience that comes from the decentralization.
Yeah, please do join me in thanking Sophie, Keith, Joaquim, and Mauro.
Thanks for listening. Remember that by taking time to learn from our speakers, you can earn CPD points from our partner CPDme. So do check out the link in the show notes. Our thanks to MSA Safety for their continued support for our podcast, and to Smart Digital for producing this series. If you enjoyed this episode, be sure to subscribe to For Every Response, the podcast from Emergency Services Times.